Everybody will need a calculator. So, calculator, you could use your phone, but please just trust me, a calculator is easier, faster. It's a lot of keystrokes to use the law of sines and the law of cosines. So, I would get a calculator. Trust. Again, you could use your phone, but it is easier to use a calculator. In your packet, so in your green packet, it shows you the law of sines and the law of cosines. It is shown right here. We've got the law of cosines and the law of sines. We're going to write them down ourselves, so you don't got to go dig them out, but just know that for this section, the next few pages, we're doing it on our supplemental notes page. And so you can go reference that as you do your exploration exam. Deriving the law of cosines, that's the first question in this exploration, deriving the law of cosines. On the front page of your homework, you have a question. So these questions, I was trying to remember which questions you have to do on your homework. The homework, as a reminder, you have solutions that are posted in the Canvas page, so you can go to those to get your solutions. To do the first two questions, which is the law of sines and the law of cosines, both of these videos, which I'll post in Canvas as an announcement with the video from today. These videos are both 2.5 minutes, so 5 minutes total for you to do the front page. If you turn in your homework for today and you didn't do the front page, which again, it's easy. You watch a video deriving the law of sines and cosines, you just write out the math, then you're not going to get full credit. You got to do the front page of the homework. Bless you. So if you want to write down on our supplemental notes, watch the videos, give yourself a little note, work these out on the front page of the homework by watching the videos. Next, the law of cosines is a stronger statement of the Pythagorean theorem. What do you think is meant by stronger statement in this case? The Pythagorean theorem. What type of triangles do you have to use the Pythagorean theorem? A right triangle. So the law of cosines works for any triangle. Now you can use it for a right triangle, it'd be overkill, but you can use the law of cosines for a right triangle. Like, why would you use this if you can use Pythagorean theorem? It doesn't make sense, but that's what makes the law of cosines a stronger statement, is that the Pythagorean theorem actually, I don't want to write it like that. I don't want to write it like that. I'm going to abbreviate as law of cosines. LOC and LOS are abbreviations for law of cosines, law of sines. The law of cosine works for all triangles, not just right triangles. The law of cosines works for all triangles, not just right triangles. Next, we're going to take a moment to actually write down the law of sines, law of cosines. I know that you already have it in your packet, but it's really important for our brain to remember things that we write down. So the easier one of the two to remember is the law of sines. It's really easy to remember. And it's actually the formula that most of us want to use if we can. So for the law of sines, what you have to have for the law of sines is a side angle pair. And if you have a side angle pair, so there are certain triangles that work with the law of cosines, certain triangles that work with the law of sines. But instead of remembering which goes with which, whenever you draw your triangle, you're going to check, do I have a side angle pair? So do I know a side length and the corresponding angle, which would be across from it? Do I have a side angle pair? Then I can use the law of sines. And that's what we'll use. It's the easier one to remember. So the law of sines, the way it's written in your packet, is like this. We have sine of A over side length A. Big A is angle, equals sine of B over side length B, equals sine of angle C over side length C. That is not the only way you can use this formula. These are ratios. So you can actually take them all and flip them upside down, and it's important. Go ahead and write them both down. Or we can use A over sine A equals B over sine big B equals C over sine big C. You can set up your proportion any way that you want to. And honestly, you'll get the correct answer if you do good math. But there is kind of an advantage. Like if you're solving for an angle, put angles on the top. If you're solving for a side length, put the side length on the top. Can you solve a problem with two equal sides? Have y'all ever done that before? No, because you can't do it. You can't do it. So my point is that even though it's got two equal signs, you're only using two of these ratios at a time, creating a proportion. So you're only using two ratios at a time. So that is the law of sines. Bless you. So you have to know an angle and a side to be able to use it. Have to know an angle and a side, because when you're solving these proportions, you can only have one unknown. So if you have an angle and a side pair, you can know either an angle or a side and solve for whatever you need to solve for. So side angle pair for the law of cosines, the way it is written. And remember that these A, B's, and C's can be interchangeable. I'm just going to write it one way. So if you look it up, it might be written three ways, as A equals B equals C equals, but I'm just going to write it one way. We've got C squared is equal to A squared plus B squared minus 2AB cosine C. I would like to point out a couple of things about this formula. So, and it doesn't really matter which way you start it, whether it's C, A, B equals. Whatever side length is here is going to correspond with the angle here. And then here are just the other two side lengths. So it could be A, B, or C. These can all kind of like shuffle out, but whatever side length is here has to correspond with the angle that is here. And these are the other two side lengths. When we're solving for this, we're going to remember that we don't want to know what C squared equals. We want to know what C equals. So let's get practice writing it all down again. A squared plus B squared minus 2AB cosine C. And we're going to say that it is equal to the square root of that. I don't know why my C looks so crazy. Let me fix that. When we're looking for side lengths, Does it make sense to have a negative side length? No. So we don't do plus and minus the square root because we're not going to have negative side lengths. Another thing that I want to jot down just to help you, because I don't want you to screw up on the algebra part, but we could also rearrange this equation to solve for the angle. Here, solving for the angle is not as difficult, but here it's a little bit more challenging. To solve for the angle, we would have big C is equal to inverse cosine of C squared minus A squared minus B squared all over 2 negative 2 AB. I could help you out and rewrite the law of sines as solving for an angle. If you're solving for an angle, you would get something like A is equal to the inverse sine of A sine B over B, something like that. So you can solve for side lengths like this, or you can solve for angles like this. You have to memorize these. The way that they're going to test you without a calculator is not going to be you actually getting decimal answers. Today on your homework, on your quiz, you're going to get decimal answers. But when you take the test, they're going to be testing whether or not you can set up the formulas. So you have to know the formulas. Like whether or not you can type it into the calculator doesn't really tell you anything. They want to know, do you know the process? Do you know how to use these formulas? Have you committed them to memory? So we have to remember the formulas, however it is you want to do so. If you do your own homework and you do your own quiz, you should be fine. This one's easy to remember. This one you might have to commit to memory. All right, continuing on. So it says that it's important to note that the law of sines, I need to sneeze. Maybe I don't. It's important to note that the law of sines may provide you with more than one answer. I'm going to just kind of, the law of sines may provide you with one answer, more than one answer, or no answer. This is called the ambiguous case of the law of sines. And this only happens with one case of triangle. And so you may remember back in geometry when your teacher was like, oh, you can't use side-side angle to prove triangles congruent. I'm not going to write it like that. I'm going to write it like this because this is how we remember. The ASS triangle, it creates problems. Okay, it's a little different. The ASS triangle is a little different. And it's a little different because you could have these 3 cases that can happen, and you can probably find a 2-minute video on ambiguous case triangles to like further look at it as well. First case that could happen is that no triangle forms at all. That's what this actually looks like, that no triangle would form at all. So this is like when you're solving for your problem and you start getting errors and things like that. Could be that no triangle forms at all. This is the most common case. Okay, most of the time, this is what happens. You solve the problem, you get a triangle. Sometimes, though, it could actually create 2 triangles where this side length can be put together in such a way that it could also swivel out and create another triangle. So there are 3 different cases that could potentially happen when you have only an ASS triangle. Only that type of triangle. Okay. So let's do some examples. I only have 2 examples to do with you so that you have more time to actually work on your assignment. The first problem, it says a 92-foot path cuts a diagonal from Mateo Street to Cove Street. It makes an angle of 68 degrees with Cove Street and an angle of 34 degrees with Mateo Street. Determine the distance saved by using the path versus walking along the street. So when we create these problems, you're going to draw a picture every time. What do you think we're drawing the picture of? What shape are we going to create? A triangle. We're going to create a triangle every time. For this problem, so we've got Mateo Street and we've got Cove Street, but we've got this path that is a shortcut. So I'm going to label it. We've got Mateo Street and we've got Cove Street. And then we've got this path that cuts a diagonal and it saves us a little time. That's what it's saying. And this path is 92 feet long. It also tells us that there's an angle of 68 with Cove Street. So this is my path. This is Cove Street. So right there, we're going to have an angle of 68 degrees. And then it says that we have an angle of 34 degrees with Mateo. So 34 degrees with Mateo Street and the shortcut. What do all the angles in a triangle add up to? 180. So can't we do 180 minus 68 minus 34 to figure out this missing angle here? What is it? Yes, I agree. 78. All right, so if I know 2 angles of a triangle, I can find the third. What if I only know 1 angle? Can I figure out the other 2 just with given information? Can I do the same trick of 180 minus 1 and figure out what the other 2 would be? No. So this only works if I already know 2. Now, if I'm looking at my picture, do I have a side angle pair? Do I have a side length and an angle across from it that I know? Yeah. So this tells me that I'm using the law of sines, but if it didn't, then I would look to see, do I have a side angle pair? And I do. I know a side length and the angle across from it. If I know a side angle pair, then I can set up the ratio for the law of sines. Also, I need to figure out just the process. Sorry, I should have identified this first. If I want to figure out, the problem says, determine the distance saved. The distance saved using the path. What do I have to figure out how much shorter this distance is than if we can just say that we start anywhere, but let's just say we start here. If I start here and I get here, you can see just from the picture that this is going to be a shorter distance, but how would we figure out how much shorter? What do we need to know? We need to know that. Yep. What else? We need to know these 2 side lengths, right? Once I know these 2, what am I going to do with it? Add them up. Add them up and subtract 92. That's going to help us find the distance. Well, I've got to find 2 different side lengths. So I've got 2 different little problems that I need to do. I can call them whatever I want. What if I just call this side length X and this side length Y? Okay, I'm going to find side length X and Y. I'm going to add them up and then I'm going to subtract 92. So I'm going to set up my 2 different ratios and I'm going to start with what I know. What I know is And so I'm searching for, I want to know a side length. So if I want to know a side length, I'm just going to set my ratios up with side lengths on the top. So, or in the numerator. So I'm going to set X over sine across from Mateo Street. The angle is 68. 68. And then I have to use my side angle pair. My side angle pair is 92 feet and sine of 78. Okay, so this is how I'm going to solve for X. I'm going to set it up to solve for Y too. So to solve for Y, the angle across from Y is 34. So sine of 34. And then I'm going to use, again, my given side angle pair. So it's going to be the same ratio here. I can't use the law of sines unless I have a side angle pair. And again, sometimes it isn't obvious. It wasn't obvious at first because we had to solve for sine of 78. From here, it's just algebra. Both of them are going to set up the same way where we want to know what X are and we want to know what Y are. So I'm going to have to get this out of my denominator and bring it up to the top and multiply. So this using algebra is going to turn into this. X is equal to 92 sine 68. So I'm bringing this over and multiplying up top, divided by sine 78. And Y is going to be equal to 92 sine 34 divided by sine 78. I need to figure out what X and Y equal, but I'm going to let you do that. That's why I made you get a calculator. So I want you to type those in and I want you to get answers. Is there anything you should do before you start typing stuff in? Check the mode. Yeah, change it to degree. You should be in degree mode because we're working with degrees. Please do not wait on somebody else to type this in for you. You need to know that you can type this in yourself. Make sure right here to close the parentheses around sine 68. You'll know what I mean when you actually type it in. What did y'all get for X? I agree. What's the units? Feet. Somebody else, what is Y? 52.6. All right, we said that we need to add up X plus Y. So we get 87.2 plus 52.6. What do we get? What? Add them. So we have to figure out what this whole path takes. Okay, 139.8, but we've got to take that distance. And remember, we need to subtract off 92. 47.8. All right, we can answer our question. The path is about 48 feet shorter. Any questions over the law of sines? We good? Moving on, we have another problem. This is going to be the law of cosines. Two flying drones leave an airport at the same time. The heading of one of them is 120 degrees and the heading of the second is 320. If the drones are traveling at 80 and 50 miles per hour respectively, how far apart will they be after 1 hour? So I'm going to kind of sketch the situation and then I'm going to create a triangle from it. So if I sketch out the situation, so I'm going to have X and Y, and I'm going to sketch out their, like the directions that they're heading. So a direction of 120 degrees, what quadrant is that going to be in?
2.
Yeah, it's going to be in the second quadrant. I don't have to be exact. It doesn't really matter. I'm just making a triangle. Whether or not I label correctly is important, but like my sketch, I need to have, whoop, I don't like that. Let's try again. So I have one angle that goes off in the second quadrant at 120 degrees, and it's heading at 80 miles per hour. Okay. The other one, 320, what quadrant is that going to be in? Fourth. Fourth quadrant, and we're going at 320 degrees at 50 miles per hour. What shape did I say that all these problems are going to create? A triangle. Okay. So I'm going to have a triangle. It's going to have, I don't know, something similar to that. We're going to have a triangle. To figure out my angle, I'm going to figure out this angle right here. That angle, I need to know a few things. I know that this quadrant itself is going to be 90 degrees right there. But what about this little sliver right here? I went 90 and then to 120. So how much is this part right here? If I go 90 and then to 120, what's this sliver right here? 30. Okay, here I go 320 and then all the way to here would be this would be 360. So how far is this distance here? 40. Let's add them up. So I've got 30 and 40 is 70. 70 plus 90 is what? 160. Okay, I know this distance here, 160. From here, I need to know my side lengths. It's asking for a distance, but the problem gives us a speed. The problem gives us a speed of 80 miles per hour. That's not a distance. But if I'm going 80 miles per hour for 1 hour, how far did I go? 80. What if the problem said in 2 hours? What value would I put? 160. Okay. So be careful, read your problem carefully. So this side length here will be 80 miles. What will this side length be? How far did I go in 1 hour? If I was going 50 miles an hour. 50. And again, if the problem was written and it said 2 miles, or sorry, 2 hours, then how many miles would I have gone? 100. Okay. So again, just be careful. I feel like it was simple that they said 1 hour. A lot of times the problem is not just for 1 hour. Yes.
As long as it's like not.
No, not really. But when it says respectively, it listed two values first. It listed 120 and it listed 320. When it says respectively, it means the first one goes with the first and the second one goes with the second. From here, it says, how far apart will they be after 1 hour? That is our question. That's what we want to find out. So we need to find that distance. So based on what we were given and what we solved, we created a triangle. Well, actually, we didn't solve anything. After making our triangle, do I have a side angle pair? No, I do not have a side angle pair. That means that I cannot use the law of sines. I have to use the law of cosines. There's no special cases with cosines, with the law of cosines. I just set it up. I want to know a side length, so I'm going to set it up, but I don't want to know the side length squared. So I'm going to have to set it up as x equals the square root of, and so it'll be the two side lengths that I do know. 80 squared plus 50 squared minus 2 times 80 times 50. Cosine of the angle that I know, 160. Every single time when you set this up, it'll be whatever side length you want to know, and then the two that you do. When I set this up, did it matter if I put 80 or 50 first? Does it matter? Does the order we add in matter? No. Does the order that we multiply matter? No, it doesn't really matter. Like I didn't label this as A, B, and C. It does not really matter which one you put first. We're going to type that into our calculator. And again, we don't care about a negative square root because we are not going to have a negative distance. So type that into your calculator and let's figure out how far. What do you get? Is that what y'all got? Okay, so let's answer our question. The question was, how far apart will they be in 1 hour? Okay, in 1 hour, they will be about 128 miles apart. When you're doing this, please keep in mind reasonability, like how reasonable is your answer? If we would have gotten 14 as an answer, would that be reasonable? No. Okay. 128, that sounds reasonable to me. And that is it for the law of sines and the law of cosines.